I'll be explaining how to prove the definition of simple harmonic motion, or SHM for short. You would study SHM if you're studying A-level physics. SHM is important to mechanical engineers when dealing with systems such as a pendulum bob or Mason's spring system. By definition, SHM is when the acceleration of an oscillating object is directly proportional to its displacement, but is in the opposite direction to the displacement. Using the pendulum bob to the left, we can prove the definition. We take the direction it oscillates into account, so we'll take the right as positive. The equation for the maximum displacement of the pendulum is given by A equals omega t, where A is the maximum displacement of the pendulum bob, lowercase t is a certain time during the oscillation, and omega is equal to 2 pi over t. Omega equals 2 pi over t because it takes 2 pi radians for the cos graph to complete one full oscillation. That is for the pendulum to go from A, pass B, to C, stop at C, pass B again and get to A. Capital T is the time taken to complete one full oscillation. It's a cos graph because at time t is equal to 0, the graph is at its maximum value and the pendulum bob is at its maximum displacement. You work out the maximum velocity by differentiating the displacement with respect to lowercase t, and you get minus omega a sine omega t. From here you differentiate maximum velocity to get maximum acceleration, which is equal to minus omega squared a cos omega t. So according to the graphs of maximum displacement and maximum acceleration, you can see they are both cosine graphs, so are proportional to one another, but they are 180 degrees out of phase, so always act in opposite directions. Now that we have the acceleration as minus omega squared a cos omega t and displacement as a cos omega t, if we are to substitute the displacement into the acceleration formula, we get acceleration is equal to minus omega squared displacement. But since omega squared is just a constant, you're left with acceleration is proportional to the negative displacement. You have just proven the definition of SHM. Thanks for watching.